amount of bass. Listener's discretion is advised.
When I was a junior doctor, I started getting interested in imaging because imaging is so important to the heart. It's, if you like, the modern day stethoscope. We can actually see the structures and how they work and plan the treatment. We're going to show you, for example, a model of how a heart works in a phantom, where we can do very accurate measurements of its blood supply that goes into the computer models, which tells us how to treat patients with angina. We're going to also show you how a PET scanner prototype that we've built works inside an MR scanner, bringing two important imaging modalities together: MRI scanning, which gives us really good pictures of the structures, and PET scanning, which tells us about what goes on more at the sort of cell levels and what is the biology underlying the disease. Because then we want to be able to target different bits of biology, and to do that we need clever bits of chemistry that allow different imaging agents which light up in PET or MR, but particularly PET, that target those different bits of biology. We'll show you a little bit about how we do the robotic ablation. You can then get a feel about how these robotic catheters go inside that heart and can do the burning of the heart, and also about the new technologies we're building to be able to do this inside an MR scanner, where we can see all the tissues in real time and we don't have X-ray radiation. We will also show you the way that we reconstruct faces and some of the microscope and other work that goes on to see whether those tissues are working well or not. We can actually watch the red cells going into this new tissue, and we can watch the cells and see how well they're working and thriving. Here, we're using images that we take in patients to see, can we classify these images into patients who are ill and who are well? But even more excitingly, can we take these pictures and tell from them if the treatment we're giving, like the drug, is working or not working? If we can develop brain scans which can tell us exactly which patients are ill and which ones are responding to treatment, that's going to be an enormous big step. Well, my vision is that we can get all the clever scientists from all the different medical engineering disciplines to come into hospitals like this and work together with the clinicians and come up with practical solutions which takes their very clever innovations and makes it work for the patient. You know, what inspires me are two things. One is when I see the patients who get better from the treatments we give them. That is the best thing in the world. And the second thing that really inspires me is when we get our teams of scientists, often some of the backgrounds who don't know very much about medicine, who come here and get so excited about what they can do in terms of healthcare, and working together come up with such clever ideas that do make a big difference to our patients.